Hey guys, so this is transformation summary level 2 and stage 1. Now this one's slightly harder than the stage 1 in level 1 or 2 or 3, so make sure you go and watch those videos. I'll put a link somewhere above right there in the top right corner. So if you take a look at this stage 1, given f at x equals the square root of dx and g at x equals negative 2 over 3 square root of 4x plus 20 plus 2. State the transformations needed to obtain from g at x to the f at x. So basically from g at x to the f at x, and as you can see, it's actually going backward, right? So from the transformed form to the original parent form. Principle of doing this is pretty much the same as the level 1, however we're just going backwards. Okay, so the first thing is always the same. We have to have the proper form. So let's take a look at this. Now if you take a look at g at x, it is not in the proper form. So let's actually review the proper form very briefly. The proper form is a, g, the function, and then b factored out from dx, and then minus a c plus d. And as you can see here, our 4 is not factored out. So we have to factor that out first. So let's then do this. It will be g at x negative 2 over 3 square root of 4x plus 5 and then plus 2 as the factored out version. So then in this case we can easily find what a is.
Negative 2 over 3, b is 4, and then c is negative 5, and then d is 2. Now remember, it is x minus c that you're comparing x plus 5 to. So that's why the c is negative 5 instead of positive 5.
So then once you find a, b, and c, and d, all we have to do is do everything backwards by removing all the transformations. We're going from g at x to the f at x, and that means we're removing all the transformations. Right? All the transformations. And when you do so, make sure you go backwards in terms of the steps wise too. Remember we did from A, B, C, and D in terms of the order wise, but now then we're going backwards, so we have to go backwards like D, C, B, and A. So we have to go backwards, okay? So as the summary wise, the order is backwards as D, C, B, A, and then the actual work wise in terms of the transformation, we also go backwards of those two. When I say backwards, what I mean by is this. For A and B, the multiplication factors, the ones that were the by a factor of, after you go back, it has to be 1. Remember, the new one times the old one has to be 1, and that is because the 1 for the A and B doesn't do anything for the transformation. That's why it has to be 1. The easiest way to find is just the reciprocal of the backwards of, so reciprocal. Then the next one is C and D. Now remember, for the C and D, these are the horizontal or vertical translations, and in order for us to nullify the effect, they have to be 0 in terms of the value, right? If the C is a 0, it does not move left or right. Same thing goes for the D vertical way. Then when the new one added to the old one, it has to be 0. Our original A, B, C, and D was
A being negative 2 over 3, B being 4, C being negative 5, D being 2.
And as we go backwards using the nullification per se, they have to reach 1 or 0 based on what type. So let's go backwards then. The D then has to be negative 2, so then they will be 0 when they're added up. Then C should be positive 5. B now then should be 1 over 4, so that when these two are multiplied, it will be 1. So 1 over 4 then. Then the A is 3 over 2 with the negative. Remember, they have to be 1 once they're multiplied. So negative times negative become positive, and the reciprocal of 2 over 3 will give 1 when it is multiplied by 3 over 2. So remember, the order goes backwards, okay?
Then our new D per se, the backwards transformation is negative 2, which then gives me a vertical translation down by 2 units, right? And then C being positive 5, then gives me horizontal translation right by 5 units. Then the next one is B being 1 over 4. Since the B value itself is less than 1, it is a horizontal stretch. So horizontal stretch by a factor of 4, which is the reciprocal. Remember, this is always the reciprocal of B value, reciprocal of the B that you have. So here the B is 1 over 4, that's why I flipped it. Now then the last one is then A, the negative 3 over 2, and that is bigger than 1, and that has a negative, so then the vertical stretch by a factor of 3 over 2, and then it also has reflection on the x-axis.
So if you take a look at this, it actually does make sense. So the original one for example, was actually moved up by 2 units. Therefore, it has to go down by 2 units to go back to its original position, right? It moved to the left by 5 units previously. So in order for us to go back to the original, we have to move it by 5 to the right. And this one was horizontally compressed by a factor of 1/4. Therefore, then we have to horizontally stretch by a factor of 4 to go back to the original, and same thing goes for the A. The transformations that you have to go through then is all these to go back to the original parent function. So the key here is very simple. So the key is reverse order with the reverse order. As long as you follow these, it shouldn't be a problem, okay? So hopefully you enjoyed the video. Hopefully you understood how the backwards of the transformation works. If you enjoyed it, if this was helpful, please don't forget to hit the subscribe and the like button for me. Thank you so much, guys. See you later. Bye-bye.